Okay, so now we're going to look at two other metapyquod containers, metapyquod-indexer and metapyquod-server. These two can work together or be used separately. The purpose of metapyquod-indexer is to generate a index for use with Meta from a website using wget. So wget is an existing Unix utility. You can install it with apt-get or with brew on a Mac or through Cygwin, a number of other ways on Windows. But it basically will do the job of crawling a website for you, and it has a couple of useful features. So I'm going to demonstrate this real quick by first looking at this file here, start URLs. So if I look at start URLs, you can see in this case it just has two websites, books to scrape and quotes to scrape.com, which is a sandbox site that exists for testing scrapers. So that's a useful tool as well, but we're just going to recursively crawl these sites using wget. So this utility's options are documented elsewhere, but you can kind of see a little bit here. We're going to be crawling the sites recursively. We're going to reject certain file extensions. There's probably a few more missing there that you want to exclude, because all we want is text files. We want text files in HTML. Maybe one day we can process PDFs, but not right now, so it's in the reject list. We're going to limit our search to anything that's in toscrape.com and not go outside of that. This is an important one called timestamping, which is going to set the modification time of the files, the modification date and time of the files that it downloads, to the date and time that is shown in the last modified header that comes from the site. That means that wget, when you run the same command again, will compare the timestamp on the file to what it gets from the last modified header from the server, and if it's not any newer, then it won't re-download it, which saves you bandwidth. Some other settings: force directories makes sure that it has a directory structure. Protocol directories make sure that it starts with a directory like HTTP or HTTPS, as you'll see in a minute. That's kind of important. There's a few options here that make the directory structure that metapyquod-indexer will need. So those are important. The rest of it is kind of configurable to your needs. Notably also, we are doing a recursive crawl, and we are crawling two entire sites, but you wouldn't have to do this if you already had a large file of specific pages. For example, the faculty pages that have been submitted or directory pages that have been submitted. You could actually just crawl those, not use the recursive switch, and it would download and create an index. So not exactly what you need for one of those homework assignments, but a similar type of use case. It would generate an index off of those arbitrary URLs without crawling. So if you already know all the URLs that you want to index, it can do that for you too. You just put all those in one file, don't do a recursive crawl, and use the same tool. So, well, I'm going to need that, so we're going to take this command and run it here in a second. Leave this file, but we know what's in it. So you'll see there's already a directory here called crawl data. That's where the data is going to go, and you can see what will happen is it'll start to crawl that site, download the things. If you're watching very closely, or if we see some of the output towards the end here, you can see it is examining the last modified header. That will save some of its work in downloading the files where that helps. So now we have an entire crawled directory structure within crawl data. So I can do tree crawl data, and you can kind of see what it looks like in there. So inside the crawl data directory, we have an HTTP directory. If your recursive crawl crawled HTTPS, there would be a second directory at this level, books to scrape.com, catalog. So you can see what is going on here. You can reconstruct the URL from the directory structure that is here. Now this is all wget. I haven't even talked about metapyquod-indexer yet, but metapyquod-indexer is going to rely on this directory structure and the files that are gathered in it. Notice we have a whole bunch of HTML files from this site. So now that we have some crawl data, we will run metapyquod-indexer. So docker run dash rm, because we don't want this container hanging around. We're going to mount some volumes. Okay, the current working directory / crawl data. Okay, I want to mount to var mirror, so that it expects the crawl data by default to be in a particular place, and -v pwd, the current working directory / index. I think. Let me tab complete that, and you can see what's really happening here is it's the shell is auto completing the print working directory command. So Docker is really getting an absolute path here to the directories you want, which is important because if you're mapping volumes, it recognizes the fact that it's an absolute path. Says, oh, I want a location on the file system to be mapped to this volume. So that's again kind of out of scope, but that's what's going on there. So, but I want to map my index directory to var idx, which is the default location within the container that it expects to find the index. Okay, and I think I've got it there. And now that those are the things I need to configure, I just run the appropriate container image, metapyquod-indexer. Okay, we'll wait a moment for that to complete. Index path exists is not an empty directory. It will not blow away an existing index. So if you are running this a second time, you'll need to have an empty directory. So rm-rf index. Okay, clear out that directory. Try it again. Wait just a minute or so, and we should get a output in our index directory, which is a meta index, right? So we have a config.toml in there, some stop words that come with a container, and an index directory. This is creating just an inverted index, by the way. So if you need a forward index, you might need to modify this a little bit, but that's possible. So if we look, kind of an important point here. So if we look at that config.toml, notice when we ran this container, we said, hey, put the index in this location. Now that's location inside the container, and it's an absolute path. The config.toml, I had a good deal of trouble figuring out how to make this work without repeating the same path, and it's usually almost crucial to have it be an absolute path. You could do it with a relative path, but they don't always make too much sense. So what metapyquod-indexer will do is it will set in the config.toml file the absolute path that the index is created at, and that's the absolute path the index is created at within the container. So in this case, and by default, var idx. So you can see that if you look at config.toml, you can see the prefix that's set in there is var idx, and the that's where it knows to look for the stop words. That's where it knows to look for the actual index directory, which is inside of there. So there's obviously a way to change that if where you're going to use the index, and that's what's important. Where you're going to use the index in some application that uses the meta library, you have to be able to put this index where that path is going to come up with the correct file. So obviously you can edit the config.toml directly. That's easy enough. But you can, in fact, pass it some useful options, and in fact those are pretty well documented for you here. If you just run the help switch, it should show you a couple of options. So the default, for example, the mirror path is var mirror. The default for the index path is var idx. But you can change that if you've mounted it at a different place within the container, if you've mounted the var idx directory to someplace else, and you've got multiple, you want to be able to put multiple indexes in a place, you can specify which one. You can also leave the generation of the index at var idx and specify explicitly the prefix. which will override what gets put into the config.toml, kind of direct to the point of what we're talking about there. There's also a dataset identifier that you can specify. Again, if you look at the config.toml, there is this value right here, which can be useful because this comes through when you load the index up in your application as the corpus ID or the corpus name, I think it is. So if you want to introspect, or if you have multiple indexes you have to deal with, that can be useful to discriminate between them. So you can set a couple of those values within your options when you run the indexer. So all that done now, I have a meta index here, but without having an application to actually use it, I can't really show you too much about it other than the directory structure that's in there. It is worth saying one other thing about what it does. It has, and you can see it here in the config.toml, it has embedded some metadata for each of the documents into the index. This is a feature of the meta indexes where you can have a couple of metadata fields. Classification is one that's talked about in the documentation if you're actually doing a classification job. But what the indexer will do will embed 3 metadata fields, and that's a title. So if it's an HTML page, it uses Beautiful Soup to extract the title from the HTML, and it will put that in that metadata field. The URL that the page was originally retrieved from, and that is reconstituted from the directory structure that wget created. So could be a flaw there, but so far it works pretty good. And that modification time, which may be useful for you. But those 3 fields are actually available in the index data as metadata. And we'll kind of see how that is important or useful here in a second. So I have this index that I now want to use, I want to do something with. So I'm going to use it with metapyquod-server. So that's another container. So I'm going to say docker run rm, mount a volume again, pwd/index. We're going to mount it at var idx again because that's what the config.toml has burned into it, and that's a location that's prepared in metapyquod-server for you to put your index at. I'm going to then tell metapyquod-server where that index.toml file is exactly. So I'm going to say, an environment variable to the container, metapyquod-idx.toml. Location is var idx config.toml. And then I'm going to forward through the port that the server uses, which inside the container it runs on port 8080. So I will pass that through to the host on port 8080. Actually, that's backwards. It's the host port and the inside port first. But yeah, they're both the same in this case. And then I'm going to run the server container. That's on Docker Hub, so if I haven't cached it already, it'll download it, and I have, so it's started. So now the server's running. So what does the server do? The server provides just a REST interface that you could build another application on top of. You could build a website with a, like an Ajax client, or you could build a mobile app if that suits your purposes better. But the bones are here to be able to build a search function, a search service based on the index, whatever index you pass into it. So we can start looking at that by looking at the Swagger UI, which is provided in the server, that tells you about the services that it provides. So it gives you a OpenAPI spec if you want to read the actual JSON spec. There it is. But it also gives you this nicer user interface that you can see what kind of services the server provides. And it provides 3 main services, basically. A search service where you can search the index, a feedback service for gathering implicit feedback. So this is a click-through handler similar to the click-through handler that Google uses when you use their search engine, and a telemetry service. So we can actually exercise these service endpoints directly here from the Swagger UI. So let's run the telemetry stats service and see what we get back. This will give you just some basic information about the index and what is in it. So if we execute this, you'll see essentially it does this request against this URL, and we can see what it returns. So the stats about the index are it has 1,181 documents and 14,000 unique terms in it. So we could say, okay, good. Well, we have an index. It seems to have stuff in it. So then we can come up here and search that index. So we try it out. We can provide some parameters. We can provide some search query, and then these two parameters are for pagination. So I want to get the top 10. If I wanted the third page of the top 10, or third page rather, of pages each of 10 items, I would say skip 20. That will give me the next 10 after I skip 20, so that's pages 21 through 30, or results 21 through 30. I don't want to do that because I don't think I'm going to have that many results, so I'm just going to say I'm going to search for the term attic. So one of these is a bookstore that has been crawled, so what we're going to get is two results. We're going to get a result for Shel Silverstein's A Light in the Attic and a result for The Diary of Anne Frank. So there you go. That's some sensible results from the index from the website that we crawled. So that's basically it. So you could then write on top of this a mobile app or a website that actually uses the index. You can pass whatever index you want to through to the server, and it'll use it. Prepare that index metapyquod-indexer. The only thing kind of worth showing here is this click-through utility. So so over here when we did the search, we got some results. So the service actually brings back the score from the ranker. You probably wouldn't display that to the user, but it's available for you to look at if you wanted to. You could display this information to the user, and then you could take them to this URL, but what you may want to do is instead use this doc ID that is provided in the search results. Okay, dataset.32. Dataset is the ID that we provided here within the config.toml. Remember that. And this is document number 32 essentially in there, but it's the ID of that document that came up in the search results. So you could take that ID then and use it in the click-through handler. So what this would allow us to do, now there's no actual code within the server at this point to do anything with this information, but it's there. You could add that code to the Python if you wanted to. But the idea here is that you would send the user, rather than directly to the URL, you would send them to this service, which is /click/query. So we would record that our query was attic. Again, that's nothing that is actually done with that value at this point, but it would be available if you want to implement this handler. And then the doc ID. So dataset.32 was the result, the first result from our search results. And when we hit that endpoint, what we actually get is not JSON, but what is sent is a 302 header. A 302 header and a header value, a location header value, okay, right, that gets sent. So what we can kind of show you a little bit differently is if we use this curl command, right? So I'm going to come over here, give me another console window, and we'll run this curl command, and you can see what comes through. And I'm going to add some V's to that curl command so we can see some more information. So we run this, and what we see is that a 302 found header is sent, and there is a location header that is the original location. Okay, so what happens is you would send your user to this location, and we can demonstrate this if we actually go to the browser and paste this into our location bar. What happens is the user would go here, it would bounce off of our service, which we could record, and then it would take them directly to the search result. So the user is taken smoothly through to the search result, but we got the opportunity to take some action. If you wanted to gather implicit feedback for doing something like Braccio, you could do that. or just gather metrics on how it is that the search results are being used. So you can see how that works. And that is metapyquod server.